Okay, let's get into it. Today we're taking a deep dive into something really fundamental. Our sun, the star that basically runs the whole show for us.
Mm.
Where did it actually come from? I mean, it wasn't just there, right?
Hmm.
We've got some source material here that describes its birth billions of years ago, and it sounds pretty dramatic.
Yeah, it really is. And we're using this text to sort of pull out the key moments for you, the surprising bits in how the sun actually formed.
It's quite a journey, isn't it? From just like gas floating around to a star.
Exactly. So picture this maybe 4.6 billion years ago. There's no sun. What you do have is this just enormous cloud of gas and dust out in space. The source calls it the solar nebula.
And we're talking huge, right? Like mind-bogglingly vast.
Oh, absolutely massive. And interestingly, this cloud needed a nudge. It didn't just, collapse on its own.
A nudge.
Yeah, the source points to maybe a shockwave, possibly from a nearby supernova, an exploding star. That might have been the trigger.
Wait, hold on. So another star dying might have actually caused our sun to be born.
It's a leading theory. Kind of amazing, isn't it?
That is incredible.
Yeah.
Almost like chaotic. Okay, so it gets this trigger. Then what? Gravity takes over.
Precisely. Once it's disturbed, the cloud starts collapsing inwards, just gravity pulling all that gas and dust together.
And it speeds up as it falls in, I assume?
Uh-huh. And something else happens. As it collapses, it begins to spin faster and faster.
Ah, okay, like the classic figure skater pulling their arms into spin quicker.
That's the perfect analogy, yeah. And this combination, the collapsing and the spinning, it flattens the whole thing out.
So it doesn't stay a big ball of gas.
Nope. It becomes this huge rotating disc, like a cosmic frisbee made of gas and dust.
Okay, a spinning disk.
Right.
And I guess most of the stuff ends up in the middle?
The vast majority, yes. It spirals down, gets pulled by gravity right into the center, piling up. It gets incredibly dense, incredibly hot. This central part is what we call the protosun, the beginnings of the sun.
Proto-sun. Okay, so it's getting denser, hotter. What kind of temperatures and pressures are we talking about in there? Is it, like, unimaginable?
Pretty much. The source describes pressure millions of times what you'd find at the bottom of our deepest oceans, and the temperature rockets up to millions of degrees Celsius. Just extreme conditions.
Wow. And that's the point, isn't it? When it gets hot enough, dense enough, something has to give.
That's the ignition point, nuclear fusion.
Fusion.
The core gets so extreme that hydrogen atoms, which were the main ingredient of that original cloud, are forced together.
Squeezed until they fuse.
Exactly. They fuse to form helium, and doing that releases an absolutely staggering amount of energy.
That's the light. That's the heat. Our sun switches on.
The star is born, starts shining. That outward push from the fusion energy finally balances the inward pull of gravity, and you get a stable star.
Amazing. So, okay, the sun's lit up in the center. What about all the leftover material in that spinning disk around it? That didn't all fall in.
No, quite a bit was left orbiting, and over, well, tens of millions of years, that material started bumping into each other, sticking together.
Building things up.
Yeah, through a process called accretion. Little bits form bigger bits, which form planetesimals, and eventually those clumps grow into the planets, the moons, asteroids, everything else we see today.
And the new sun must have had an effect too, right? Blasting radiation outwards.
Oh, definitely. This solar wind, the stream of particles, and the intense radiation from the young sun helped clear out a lot of the remaining gas and dust that didn't get incorporated into larger bodies.
So let's just recap this incredible story from the source. You start with a giant, cold cloud. Maybe gets kicked by a nearby star's death. It collapses under gravity, starts spinning, flattens into a disk.
Right.
Most stuff goes to the center, forms a super hot, dense core,
A protosun.
and bang. Fusion ignites, it becomes a star, and the leftovers form planets.
You've got it. It's this elegant, complex process driven by physics. Gravity, spin, fusion.
It really puts things in perspective. And just before we finish, there's one fact from the source material that just blows my mind.
Oh, yeah. Which one?
The sun. It contains about 99.8% of all the mass in the entire solar system.
It's an incredible statistic, isn't it?
99.8%. Everything else, Jupiter, Saturn, Earth, all the planets, asteroids, comets, that's just 0.2% of the leftover dust, basically.
It really underlines its dominance.
Totally. So here's something to think about. What does that overwhelming concentration of mass, that 99.8%, actually mean for how everything else is structured, how it orbits, how the whole system behaves? Its gravity just dictates everything.
Yeah, that gravitational dominance shapes absolutely everything we see out there. Definitely food for thought.